Hello, welcome back. Today I'm going to continue by doing week 2, number 1, first bad version. So this is Leetcode number 278, and it reads, "You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all versions after a bad version are also bad." Okay, so it's just a lot of bad versions. Suppose you have n versions starting with 1, 1, 2, dot, dot, dot to n, and you want to find out the first bad one, which causes all the following ones to be bad. Okay, you're given an API, returns bool is bad version, takes a version, which returns whether the version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay, so in the example, the input is n equals 5, and I guess the secret answer is bad equals 4, right? And the output that you should have is 4. So the explanation is bad 3, is bad 5, is bad 4. Okay, so there's no rhyme or reason to this, to these calls, but 4 is the bad version, right? Okay, so let's think about what we have here. It's setting itself up to be a Boolean search type of problem, and I realized there was a tag in the list, but what we're thinking about is like what they're giving us is something where the input could be in a number line, right? And this is 1, 2, dot, 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 all the way to n, right? And they're saying that given some method is bad, let's say it takes n and returns a Boolean, returns a bool here. This can be called in any one of these. And let's say the first bad is a random one that's here. Everything to the left of first bad is green. Everything to the right is red, right? So everything is, so once something goes bad, it doesn't go back to good. It just stays bad, right? So if you think about in your own experience what mirrors this functionality, this is actually git bisect, right? So git bisect will take a list of commits, and if you pass it some commit, it will help you do the binary search, right? So it's going to say, you know, if you give it this commit right here, or sorry, if this is your current commit, and you say, let's look up to here, it's going to search in the middle. It's going to ask you, does this one look bad? If it does look bad, then you have to go even earlier, right? And then earlier, and you can imagine this is the binary search concept, right? So this maps directly with this, right? So it's green for a little bit, and then it goes red, and red is bad, right? And what can you do? You can say, let's take the middle, right? This is the middle point. I don't know why I made the arrow so long. This is the middle point. And we can call a check. We could say, is this bad? And if it is bad, then we know that everything to the right of it is also bad, right? So this is the information that we have. Everything to the right of it is also bad. So is this the one we're looking for? Is this the first bad? So what is first bad, right? So first bad is, it's a check where it's bad. So right, so the self is bad, right? And then immediately to the left, so the first left is good, right? So this first bad right here, I'm just going to make this red. And make this also red. The condition here is that this is bad, but immediately to the left of it, this is good, right? So that's a condition for first bad. Is this mid first bad? It's not, right? So since it's not, then we want to change our search. So now our search just going to move this here, is we're going to take this right pointer, right, which starts at the right end of the list, and we're going to make the scope of the list smaller by moving this right pointer to mid minus 1, right, to right there. Not mid, because mid we already know is not going to be our answer, so we don't need to have mid in our range. We can move it to that minus 1. What is the mid of this new one, right? So the mid of this new one is probably here, let's say, right? And this is bad? No, it's not. It's not bad. So what do we know if it's not bad? If it's not bad, then we know that everything to the left of it is good, right? So if this is good, we know that nothing before it broke it, right? I mean, in a real situation, if you're using git bicep, there might be more than one bug. But if you're looking for just this bug, we've now done the same thing. We've narrowed the scope of possible solutions in the solution space, right? So that means we can move left. And we're just going to continue doing this, you know, find the mid and iterate until that first bad is found. And that's basically it. So, you know, what does that look like in code? Well, in code, this is a regular binary search, right? So, binary search. It's not a strict binary search. It does other stuff. So I'm just going to write solution here. So, what is the solution here? So, you want to start left, and left is not 0, right? So actually based on here, it goes from 1 to n. So left is not 0. Left is 1. But right is n, right? So the solution takes, I don't like how this is written. The solution takes n. And then we start our left and right. So let me just add a comment here. So we do starting points. And then we do iteration, basically, until we find our solution, right? And what does the iteration mean? It means a while loop. So while left is smaller than or equal to right, right? Because they can be at the same point. So if left and right are at the same point, let's say they both end up here, well then that's the midpoint that we're going to be searching for, right? Because left plus right divided by 2 floored is going to be that. It's going to be that position. Okay, so while left is smaller than or equal to right, then, you know, we're going to find that midpoint. We're going to do this step right here. Right, so find mid. So mid is what I just said. It's the floor of that left plus right divided by 2, right? Perfect. So if bad, we're going to do something. And then if good, we're going to do something else. So if bad, we don't know that this is the first bad. If bad, we just know that we can, you know, narrow the scope. So how do we know if it's the first bad? If it's bad, then if mid minus 1 is good, then we want to return, right? So this arrow is going to signify return. And we're going to want to return mid because this is the point. Sorry, I should have put an if here. So if mid minus 1 is good, we want to return mid. Else, if it's not good, right? If I don't know why I made these comments, but you can tell it's pseudocode, right? We'll get rid of these comments. So if it's bad, we do this. If it's, actually I really like those hashes as signifiers. I'm going to keep them. Okay, so else we're going to do what we wanted to do here, right? The first step that we did was we started with lines at these extreme ends and we moved them. So if it's bad, then we know that everything to the right of it is also bad, right? So we can move right. So right equals mid minus 1. And else, if it's good, left equals mid plus 1. And because this condition is a little bit simpler, it's possible we can move it up here and then do this condition as the else. But these are the two conditions, right? And I think we're ready to, we can go ahead and code this as long as it all makes sense. So as long as it makes sense in the diagram, it should make sense in the code. Okay, so what are we doing? Make this a little bit smaller so it can be seen. Let's just put the comments. So the starting points, we want to do an iteration, and we're going to find mid. And then if it's, let's just say if it's good, we want to move the left pointer. And then else, it's bad, then we want to do another check, right? We want to say, is mid minus 1 good, right? So if mid minus 1 is good, then we want to return. So we're going to return mid here, right? Just going to say return. And then if it's not, then this is, potentially in a whole line of bads. So if it's not, then it's potentially any one of these bads, right? It could be this one, could be that 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 one. We know it's not the first bad. It could be any one of these bads. But it's not enough for us to stop iteration, right? So what else we got? And in that case, then we want to move the right pointer. Right? So what are the starting points? So left equals 1, right equals n. What is the iteration? It's a while loop of left being smaller than or equal to right. This is a JavaScript habit, and mid equals the floor of this left plus right. Okay, so left plus right needs to be in parentheses. And then that's going to be divided by 2. And we take the floor of that, right? And that's going to make sure that it's a valid index. And how do we know that if it's good? So if it's good, we're going to say, what's that method they give us? Is bad version. So if it's not a bad version, and I'm passing in mid there, then I'm going to move. So if it's good, I'm on this green, then I'm going to move that left pointer, right? I'm going to move left. Put this comment here. Left equals mid plus 1. Else, if, okay, these comments are kind of getting in the way. If is bad version mid minus 1, so again, if it's not, which means it's good, then I'm going to return mid, right? And then if it is a bad version, then just like I said, I'm in this red. I could be anywhere in this red right here, right? It could be anywhere in that red, and if I'm anywhere in that red, then I just want to go ahead and move that right. Okay, so it's guaranteed that bad exists. Right here it says in the constraint that 1 is always going to be smaller than or equal to bad. So bad's at least going to be 1, and bad's going to be smaller than or equal to n. So bad's always going to exist in this example. All right, so case 1 and case 2. Let's go ahead and submit it, see how we did. If there's any errors, we can go ahead and fix it. All right. So it's accepted, and we have 67.9% runtime and this much memory. let's think about what the runtime is. It's a binary search. So login operations. Could we improve? It's always worth thinking, could we improve? Well, we have these starting points. We have this iteration. I don't think we can improve on the runtime in terms of complexity, but we can probably improve some of these in terms of computation. Here I'm taking these knots. I don't know if that's going to cost me here. It's possible that they want you to do it. Not that they want you to, but it's possible that because you have those extra checks, you're doing that Boolean inversion, then maybe you want to check for is bad version first, right? So maybe you want to do something like, if it's bad, then we do these things, right? What happened? Did I not copy the whole thing? Okay, so if it's bad, and then it's bad again, we actually just move right. But if it's, uh-oh. I really wish I had Vim. Or some keyboard shortcuts. Okay, so if it's bad, we iterate, we move that. So let's just get rid of these. And if it's good, we move left. So it's possible this is faster, and I realize that, if I just run the same code twice, these runtimes are going to be different. You see, it's slower, but it shouldn't be slower because it wasn't. I'm back to 67. Okay, well, thanks a lot. Let's not worry about the runtime percentile of Leetcode as long as you understand the runtime and the memory needs of the actual algorithm. So, I did all those changes. Complexity is still of binary search and O of login. Thank you very much. This has been First Bad Version. Please like and subscribe. And thanks a lot.